Hi everybody, welcome to AD3301 Data Exploration and Visualization. Unit 5 Multivariate and Time Series Analysis. Important and frequently asked questions we are going to discuss in this video, both part A and part B. The first question is define causal explanations in data analysis, or what is the concept of causality? Now, so you must understand this a very important term, okay? Causal effect or causal explanations. So what this means in data analysis, causal explanation means it is a process of identifying and understanding the cause and effect relationship between the variables. Okay, for example, you can take x is a variable and y is another variable. So x is going to affect y. So x we are going to call cause, and this is we are going to call effect. So this type of relationship, if you observe, that is called the causal effects. Now, so the first variable we are going to say as a cause. Okay, the next variable we are going to say as a effect. So the relationship between these two variables is called causal. Okay, it's a causal effect. Now, what are the key characteristics? Important characteristics of causal explanation means identification of cause and effect. You have to identify which is the cause and which is the effect. Then establishing a relationship. So there is a relationship between this. Okay, so what that relationship means? You can see here. Is it a direct relationship or indirect relationship? Okay, so it's in this case it's a direct relationship. Okay, x is directly affecting y. So indirect means you can have one more variable here. Okay, x comma y comma z. So x is having some impact on y and y is having some impact on z. So in this case we are going to say it is having an indirect effect. Okay, then the direction of influence. So direction means like the flow. So in which direction the effect is flowing. So these are all the key characteristics. You can see an example here. Cause. Smoking is a cause. So I'm taking the variable s. So s is a variable. I'm going to say it is smoking. Then it's having a direct impact on LC. That means the lung cancer. So causal explanation shows that smoking is directly contributes to the lung cancer. So this is called causal effect. So it's a very important concept as far as multivariate is concerned. Question number 3. Explain the role of causal explanations in predictive modeling. So we must know what is predictive modeling first. So then we can find, okay, what is the role of causal explanations in predictive modeling. Okay, so what is predictive modeling? Means generally predictive modeling is a system or a model or a software, okay, whatever it could be. So by using the historical data, it can predict the future. Okay, in future, what is okay, you can forecast the things. So this is called the predictive model. Okay, you can see here. Predictive modeling is a process of creating the mathematical models that uses the historical data and make the predictions about the future outcomes. So this involves identifying the patterns, identifying the relationships, okay, within the data and forecast. So three things. So identifying the pattern, identifying the relationships, and then forecasting the future events. Okay, what is going to happen in the future. So this is called the predictive modeling. For predictive modeling, the causal explanation plays a major role. Okay, how you can see here. So understanding the relationship or understanding the causality. Then improving the model accuracy, prevents the overfitting, better interpretability, and then guiding in the decision making. So these are all the ways in which excuse me. So these are all the ways in which the causal effects or the causal explanations will help the predictive modeling. So this is a short answer question. Question number 4, 5, and 6. Okay, if you see, so they're asking us to draw. Okay, so what does that means? This is called causal path diagram. Okay, causal path diagram. So we have to draw a causal path diagram. Okay, so question, they rephrase the question. You can see, draw a causal path diagram for cause of absenteeism, okay, from work. Depict the direct effect relationships in terms of the cause of absenteeism. Depict the indirect effect in terms of gender and absenteeism. So what the question is? They're asking us to draw the causal path diagram. Okay, now, so I'm taking three variables here. So first variable is a female. Second variable is a low status job. Then the third variable is a absentee's behavior. Okay, this is the example I have taken from the book. Okay, so you no need to check any logic in that. So whatever the example available in the book, we are using it here. Okay. Now, so female employees, they have, okay, more absentee's behavior. That means they are absent, more absent for the jobs. So this is a direct impact. Then female employees, those who are working in the low status or low grade, so they are taking more absent. That means they are more absent for the jobs. So this is the absenteeism behavior. So what does it means? Here, female employee is a variable, low status job is a variable, absenteeist behavior is a variable. So female directly they are having the impact. Okay, it's a direct relationship or direct effect. Okay, on the absenteeism. And the indirect effect you can see here. The indirect is okay through the job status. Okay, so this is a very simple causal path diagram. Okay, so explanation is given here. You can see here the figure illustrates a system with multiple causal effects. Individuals in the low status jobs tend to have higher absenteeism rate. Okay, this is a concept. So there are two relationships we are deriving from this. One is a direct effect and second one is the indirect effect. So what is direct effect? Women are generally more likely to absent than men regardless of the job. So whatever the job it could be, so they are more absent to the job. Indirect effect is, okay, you can see here, women more likely to hold low status jobs. So we are bringing another variable here, low status jobs. So which is linked to increased absenteeism. Okay, so this is the concept. So example only, okay, you no need to see the fact whether it is fact or not. Okay, we no need to see that. The example is given, we are just following the example. So in exam, so you may ask to draw a causal path diagram. So with 3 variables, even sometimes with the 4 variables they may ask. Okay, so you must be very careful. You have to mention the which is the direct relationship and which is the indirect relationship. That means direct effect, indirect effect. You have to write it properly. Question number 7. Explain the concept of longitudinal data. So this is a very important concept in lecture number 5. Okay, so longitudinal data. So what is longitudinal data means? The data which is collected, okay, for a very long period, okay, over a period of time. For example, temperature of a city, rainfall in a country, okay, share market observation, okay, that means index like Nifty or Sensex, whatever it is, okay, observing for a very long time. That is called the longitudinal data. Okay, so you can see here, longitudinal data refers to the data collected from the same subject. The subject will be same, okay, repeatedly over a period of time, very long time. So understanding the changes, how the data is changing, what are the developments in the specific variables, okay, how a specific variable is changing, then what is a trend, what is a pattern, and what is the causal relationships. So all these things you can observe for a very long time, okay, even in months, okay, years, okay, even in decades, okay, you can go for 10 years, okay, decades also you can go. So this is longitudinal data. Now, characteristics of longitudinal data, there are 3 characteristics we are mentioning here. One is the repeated measures. So you have to measure, you have to observe it repeatedly. Okay, so multiple observation of the same variable, that is the same subject, for very long time. Okay, very long time. Okay, so you have to observe it. Then time dimension is very, very important. Okay, that means the frequency. So for annually or quarterly or monthly, okay, or weekly, so a very long time will be observed here. Then individual tracking. So by following the same entity over a time, so you are going to follow the same object, a single subject we are going to follow. Okay, so these are the characteristics of longitudinal data. So example you can see here, health studies. So tracking a patient health, okay, outcomes over several years to evaluate the long-term effect of treatments and interventions. So the health observation of a patient. Okay, so you have to observe for at least 6 months or 1 year. Okay, for some reason. Then educational research. So people, those who are doing the research, they observe the data for a very long, even multiples of years, they observe the data. Economic surveys. Okay, so if you take for every country, the economic survey is available. So they observe the data for 1 year. Okay, for every year, they will submit the economic survey report. So longitudinal data collected over a period of time. Okay, it's a very important concept as far as lecture number 5 is concerned. Question number 8. This is a very important question. frequently asked university question. Difference between time series data and longitudinal data. It's a very important 2 mark question. Okay, you can see here. So we are taking some features, okay, like definition, the nature of the data, structure of the data focus, the purpose of the data, and the example. Okay, so these are the different features we are taking. So we'll go for the definition first. So what is a time series data and what is a longitudinal data? So time series data means the data collected at a regular interval of time. Okay, so there will be a break here, so regular interval. So that means every 30 minutes I'm going to collect, or every 5 minutes, okay, I'm going to collect some data. So that, but longitudinal means data collected from the same object over a time. It's a continuous one. The data will be going on continuously. So nature of data, you can see focus on one variable over a time, focus on multiple variables over a time. So you can focus on multiple variables also. In the last slide, in the previous slide, we discussed a single subject. Okay, so you can have your multiple subjects also in a longitudinal data. For example, so I'm going to monitor the moisture level and also the temperature of a city. Okay, for continuously I'm going to monitor. So I'm using two variables here. Same. The next one you can see here, structure. A single variable repeated over a time. But here multiple variables also you can have linked by the subjects. Focus. So the patterns, trends, and season. But here we are going to focus on the changes, the relationship between the data and effects over the time in the longitudinal data. So the purpose, what is the purpose of time series data means? Analyzing the trends and predicting the patterns. So here the study impacts on variable over times. Okay, that means the impact of variables over a particular time. Example, time series is a stock price. Okay, for example, I'm just going to monitor only 8 hours. Then I have to go for the next 8 hours. Then next 8 hours or weekly based. Okay, like that. So economic indicators. So these are all time series based. But longitudinal data, you can see the health changes. So it will be a continuous one. Income over a time. Okay, so there are a lot of examples you can write. So this is a very important question as far as final exam is concerned. So difference between time series data and longitudinal data. So question number 9 is explain the significance of longitudinal data in trend analysis. Okay, so I need to analyze the trend. Okay, so how longitudinal data is important for that? Okay, significance of longitudinal data in trend analysis. Okay, we already discussed. So longitudinal data is going to be used for the trend analysis. You can find the trend. Okay, trend means the changes which is happening, pattern, okay, developments, okay, anything. So longitudinal data is collected from the same object or units over a multiple time. Okay, over a multiple time points. Okay, so allows you to track the changes. You can track the changes, you can track the developments, and you can also see the pattern, okay, across the time. Importance of longitudinal data in trend analysis. How the longitudinal data is going to help in the trend analysis means capturing the changes over the time. So what are the changes happening, okay, over a particular time we can observe here. Establish the causal relationships, how a variable is affecting another variable. Subject is one, okay, don't confuse subject and variable. Subject is one, every subject will have multiple variables, okay, don't confuse that. Okay, so establish a causal relationships, okay, that means the causal relationship among the variables about a single subject. Then provide the insight of cohort effect. So what is this cohort effect means? We can study it in the coming slide, but in a very simple way I will tell the variables which is affecting, okay, affecting your data. So that is called the cohort effect. Then so provide the insights, okay, which is the cohort effect which is affecting your data. You can find it here. Enhance the predictive accuracy, then improve the understanding of developmental stages. So 1, 2, 3, 4, 5. So 5 ways, okay, longitudinal data is helping us for trend analysis. Okay, understand the concept here. So how using the longitudinal data you can understand, okay, or you can capture the changes over a time. Using the longitudinal data, you can find the causal relationships. That means which variable is affecting which variable. So using the longitudinal data, you can find the cohort effects. That means which variable is affecting your data. Then Using the longitudinal data, you can predict the accuracy. Okay, you can enhance the predictive accuracy. Then, using the longitudinal data, you can understand the development stages. What are all the developments available in your data? So, longitudinal data is very helpful in identifying the trends. Question number 10. What is a cohort effect? It's a very important question. A cohort effect refers to the differences observed in data. Okay, you can say here the differences observed in data. That means your data is affected that are influenced by a characteristics of a specific group over a time. So because of a particular group, okay, so your data is going to be observed. There will be some difference in your data. So this is called the cohort effect. So we can say in a very simple way, a variable or a group of variable which is affecting the your nature of the data. Okay, whatever the data you collected, it will be affected by a group of variables. So that is called the cohort effect. Now, cohort effect is a simple set of population. Okay, it's a subset of population that shares a common characteristics. Okay, we make as a group. Okay, cohort is a group. Okay, a subset of the population. Okay, you know the population, the entire thing is a population. So in that, a subset, okay, they share the common characteristics. They have the common characteristics and typically defined by the factors such as the age, time period, or location. So whatever it is. So based on the time or based on the age or location, and this is going to affect the other variables, the other values or variables it is going to affect. So this is called the cohort effect. Now, what are the types of cohort effects? Means there are two things available, two types. One is the age and second one is the time. So the difference between the groups of people who share the same age but belongs to a different time periods. Okay, we can make it like this: a age cohort effect, time cohort effect. Okay, so what is that age means? It's like you take it as a age for the human being. Okay, so the people in a particular age group, so they are going to have an impact on the other group. Okay, for example, 40 plus, okay, 18 plus. So the 40 plus group is going to have some effect. Okay, they are going to influence the others. Okay, the other group. So this is called the age cohort. Then cohort. The time cohort means the difference observed between the groups of people who belongs to the different time periods but share the similar characteristics. So people before Corona, after Corona. Okay, that means before COVID and after COVID. So we can divide like this. So based on the time, you can have a cohort effect, or based on the age also, you can have a cohort effect. Okay, you can see an example. If you see the example, you will understand it better. So I'm going for the example here. Age cohort effect, time cohort effect. Okay, so what that means? Younger generation might have a different career path due to the technological advancements and compared to the old generations. So compared to your father and mother, so you'll be having a better job. Okay, so you have a lot of options now like IT industries, okay, AIDs, ML, plenty of options available. So this is called the age cohort effect. Old adults might have a different health outcomes due to the historical access to the healthcare. So actually people from different age group, okay, you can understand this. So the health of the current generation, if you compare with the previous generation, so it's very weak. So this is age cohort effect. Cohort. Then time cohort means the people who lived through the COVID-19 pandemic may have a different behavior and perceptions toward the health compared to those who lived before the pandemic. So there are two different types of cohort. Okay, one is the age cohort effect, then time cohort effect. So the same thing is applicable in the data analysis also. Ready? One, two, three. Question number 11. Explain cleaning procedure for time series data. Let me tell you a very important thing here. Data cleaning steps. Okay, it's a very important question in this particular lecture. Whatever the data it could be a longitudinal data, or it could be a time series data, or generally it could be a data set. Okay, no issues. So the steps will be same. Data cleaning steps will be same. So you can expect this question in the short answer question also, in the short, that means in the part A also, or in the long answer, that means in the part B also, you can expect this question. Okay, now I'm going for explain the cleaning procedures for time series data or illustrate the cleaning steps in time series data. Okay, so why we have to clean? Okay, what is the reason? Means suppose any type of data, okay, it could be time series or longitudinal or any data set. So there will be some challenges available. What does that means? The data will be missing. So you can find missing values in your data set. You can find some outliers, okay, irregular samplings, then intervals, that means irregular sampling intervals, and data inconsistency will be available. So all these things should be cleared. So we have to clean all these things before starting the data analysis. So cleaning time series data ensure the accuracy and reliability of the analysis. So you must clean the data before going for the analysis. So what are the steps available? Okay, for data cleaning. The first one is handling the missing values. So what is missing values? You can see in this table. So for every day, so there is some data available. So here value is 100, value 200 is available, and here value 300 is available, but this value is missing. So this is called the missing value. So how you can handle this missing value or how you can fill some value here means there are some techniques available. You can use any of this technique. So the first technique is a forward fill. Second one is a backward fill. Then interpolation. So using any of this technique, you can fill the data. So what is forward fill means? Use a latest valid data point. That means the last valid data point to fill the missing values. That means, so 200 I can take it and I can write it here. So this is the forward fill. So backward fill means use the next valid data point to fill the missing value. So I can take this 300, I can write it here. So this is going to be the backward fill. Then the next one is a interpolation. So interpolation is a statistical method. Okay, so using the interpolation method, okay, you can fill the data. There are two different types of interpolation is available. One is called the linear. Okay, linear, and second one is the spline. Okay, so there are two difference available. You can use any of this interpolation method and you can fill the data. So the concept here is you must fill the missing data. You can use any technique, whatever technique you want, forward fill, backward fill, okay, interpolation. And some people, they can use even mean, okay, median. So any different techniques you can use and you can fill the data. That means the data should not be empty. Okay, that is a concept. So this is the first step, okay, in data cleaning procedure. Then the second step is removing the outliers. Okay, so what is outlier? We already know the data which is not at all related, or we can say the data which is not available in a range. Okay, for example, you can see here. So the data here is 100 and the second data is 200, but suddenly I have 1000. So this is the outlier. Okay, so why we have to remove the outlier means, so you will not get the proper mean median for this. Okay, so the proper average you will not get. So suddenly the value is increasing because of some reason. Okay, so this value will affect the entire statistical values here. So we have to remove this or we have to change it with some other value. Okay. So what are the different methods available to remove the outliers? Means for removing the outliers, you can use the IQR method, that means interquartile range method, or you can go for the zero score method. So using any of this method, you can remove the outliers. So if you take interquartile IQR means, that means you can use Q2 and Q3, that means the 15th percentile and 75th percentile values. Okay, so Q1 means 25th percentile value, Q2 is the 50th percentile, Q3 is 75th percentile, and Q4 is 100th percentile. So you can use interquartile, that means Q2 and Q3 values can be used to fill this data. So we are filling this data here now. So we remove the outlier and we are fixing the correct value for the data. So this is second method, removing the outlier. Then the third method is resampling and aggregation. Okay, so resampling is a very important technique. So as far as this lecture is concerned, that means lecture number 5, resampling is a very important keyword. So what is resampling? So in a very simple way, let me tell, changing the frequency What is the changing the frequency? Can you give me a simple example? Yes. So you are collecting the data for every day. Okay, day-to-day basis you are collecting the data. So you are having 365 days. Okay, the data is collected for all the 365 days. So this will be difficult to handle. So what I can do means I can convert this into month. So instead of maintaining the data for every day, I can change it for monthly. So if you do that, that is called the resampling. So changing the frequency. So you can go for the resampling method and also you can go for the aggregating. Okay, aggregation method. Okay. So in resampling, there are two different types available. Okay, down sampling and up sampling. So aggregating the data to the higher frequency to the lower frequency, from higher frequency to the lower frequency. So if you go from a higher frequency to lower frequency, that is called the down sampling. So just opposite. Okay, if you go from the lower to the higher means that is the upsampling. Okay, so you can use any sampling method and you can aggregate the data. Okay, for example, you can see here. So daily to monthly resampling. Okay, so the data given here. Okay, if you see the data given here is every day. Okay, 1/1/2023, 2/1/2023, so 3/1/20. So this is for every day is available. Now I'm going to convert this for every month. Okay, so based on the month, I'm aggregating the data. Okay, so this is a very simple example for resampling the data. So resampling means changing the frequency of the data. Then the next method, which is the fourth method, okay, called removing the duplicates. So in the data cleaning, so removing the duplicates is a very important step. So where is the duplicate means you can see here. So this is the data which is duplicated. So 1/1/2023, 1/1/2023. So the data is repeated here. 100 is available and here 200 is available. So you can apply any method. So you can keep the first one, remove the second one, or remove the as you wish, or you can take an average of these two. So you can use any different technique, whatever the technique you want, you can use it. But the data should be, that means the duplicate value should be removed. So this is after removing the duplicate values. Now, consistent data or consistent date formats. Okay, it's not data, date formats. So what does that means? You can see here. This is here I'm using a different date, and here I'm using a different date format. You can change all the date into the common format. Okay, so we are just going for this particular format I'm writing. So this is all the steps available in the data cleaning. So it's a very important short answer question, and also okay, it's a very important long answer question. Okay, the next question you can see here. Mention the process of data cleaning with the example. So the same thing. So you already know the concept. I already explained the concept. Okay. Sometimes they will give the data and they will ask you to apply all the steps. Sometimes, okay, they will ask you to give your own example. Okay, you can see here. So the first one is handling the missing values. So no need to waste the time here. So missing values. Okay, this value is missing, and here the value is missing. Okay, here the value is missing. So you can fill all these values by using any of the technique you know. Okay, this is none means the complete row I'm going to remove. Okay, so Alice, Bob, David only I'm going to have. So this none value completely we are going to remove here. You can see the table, the solution. So 35 is available, and then I'm going to fill some value here. Okay, you can use any technique. Already we studied what are the techniques available for filling the missing values. Then the same thing here, removing the duplicate values. The duplicate values should be removed. So Bob is duplicated here. Okay, so the duplicated value should be removed here. The next one is standardizing the date format. So this also we already studied. So here you can see a different date format, and here a different date format, and here they are following a different date format. So all these things should be converted into your common format. So this is a common date format. Date. So removing the outliers. So in this case, you see here 100 is okay, 200 is okay, 300 is okay, but these two values are the outliers. So 1000, 1500 is outliers. So we must, okay, delete these outliers, and we are going to write it. So any technique. So we already studied IRQ is one of the method. So by using the IRQ method, IQR method, so interquartile method, so you can use and you can fill the data. Then converting the data types. Okay, you can see here. ID, student ID is the age, then salary. So what I want to do means I need to convert everything, okay, into a same data type. Okay, for example, convert ID to the integer, age and salary to float. Okay, so converting this particular step we didn't discuss in the previous question. Okay, so you can include it. So you can combine everything and you can write the long answer question. So converting the data types. So common data type. Okay, I'm converting everything into a common data type except ID. ID I'm keeping it as integer. So age and salary I'm converting it to the float. Okay, so these are all the different techniques available to convert the data. Okay, that means cleaning the data. Okay. Now the next important thing we are going here, define resampling in time series data, or you can see one more question also here, explain the concept of resampling frequency in time series analysis. So in a very simple way I'm telling, resampling means changing the frequency. So here you can increase the frequency or you can decrease the frequency. So you can do anything. Okay, so that is a very important one. Even you can expect this in the 8 mark question. Okay, the part B, they can give it as a 8 mark question also. Okay, now I'm going for what is resampling. So resampling is a process of changing the frequency of the time series data to create a new data set with a different time interval. So we are changing. Already the original data will be available. So from the original data, you can change the frequency and you can take one more copy. Okay, a new data set will be created. So resampling technique is particularly used for various types of analysis and applications, including the data smoothing, aggregating, interpolation, missing values. So for different applications, we are using this resampling. Okay, resampling. If you become a data scientist, definitely you will go for a resampling techniques. Okay, because keeping the entire data set will be a very difficult. You cannot handle the whole data set. Okay, it should be like minimized, or in some cases the data set will not be enough for you, so in that case you have to expand the data set. Okay, so for that you can use the resampling techniques. So what is the key concept here means changing the frequency and then aggregation. So these are two important concepts of resampling. So the first one you can see, so resampling, that means the changing frequency means allows you to convert the time series data from one frequency to another frequency. Example they are giving, converting the daily data into a monthly data or hourly data into a daily data. Okay, so I'm converting the daily data into monthly, hourly data into daily. So this is particularly useful when you want to analyze the trends over a different time scale. Then aggregation means the same thing. Aggregating means combining together. You can find here. So when downsampling, that means when reducing the frequency, resampling type involves aggregating the multiple data into a single value. Okay, you are just aggregating everything to a single value. Okay, for example, mean, sum, count, minimum, maximum. So these are all under the aggregation. Then, so you can go for the interpolation also. So there are two different types of interpolation available, but we are not studying in our course. Just they are mentioning the names. Okay, so here when upsampling, increasing the frequency, resampling may require estimate or filling in the missing values. So when you are going for the increasing the frequency, some values will be missing. So definitely you have to fill the missing values. Already we studied this method. Okay, so forward fill, backward fill, linear interpolation. Okay, you can use any of this method. Okay, spline interpolation is also available. One more method is available. So you can use any of this method and you can go for you can fill the missing values. Then so handling the missing data, we already discussed about this, how to handle the missing values. Okay, question number 16, write about the types of resampling. So we already discussed this question. Okay, no need to repeat it again. So you can write what is resampling first, then what are the different types of resampling you can write. So there are two types available. One is the downsampling and second one is the upsampling. So in the downsampling, the frequency will be reduced, reducing the frequency of the data set. And this is increasing the frequency of the data set. So already we explained this enough. So you can write it, okay, by using that. Now let me go to the next question. Question number 17. It is also related with the resampling. Okay, so write about the types of resampling using example. Okay, so sometimes they will give the example and they will ask you to apply the resampling, or they will ask you to give your own data. Okay, so here you can see this is the data we are taking here. Original data, temperature data set I'm taking. Okay, so you can see here for every day. Okay, so first, second, third, fourth, fifth, sixth, up to 10th of January 2023, the data is available. Okay, we have the temperature here. Now we are going for resampling. So we can increase the frequency and we can decrease the frequency. So this is the normal. That means day by day. So we are collecting the data day by day. So I'm going for uh, changing the frequency now. Okay, converting from the daily to the weekly average temperature. So this is down. So down sampling we are doing. So from daily to the weekly. So I'm going to take 7 days. Okay, for example, first of January. Okay, then I'm going for the 8th January. So that means for 1 week, this is going to be the average temperature, and in the next week, the average temperature is available here. So what does it mean? So here there are seven data available, 7 pieces of data available, and here we are having the 7 pieces of data. So all the 7 pieces of data, 7 plus 7, okay, that means the total 14 data is available in the data set. So we just minimize as 2. Okay, so we decrease the frequency. Then convert from daily to monthly average temperature. Okay, you can see here. So instead of having the whole month, okay, so I'm going for only just, if not, I'm not writing all the 30 data here. So I'm just converting for 1 month. Okay, from the daily to monthly average temperature. So the monthly average temperature is 22.25. Then aggregation of the results. So what is aggregation means? So giving the mean, sum, count, minimum, and maximum. So the 5 values if you give, so that is a aggregation function. So this is the mean temperature and this is a sum temperature. You must know how to find the mean value. Okay, it's available in lecture number 3. Okay, lecture number 3, you might have studied about this. Okay, the formulas, different formulas available for finding the mean. Then count, okay, minimum, maximum. So these are all the aggregation results. So sometimes the data will be given, otherwise you have to use your own data and write it. So the next question is illustrate the importance of resampling in time series data. So what is the importance of resampling? Why we need to do resampling? So this first part is going to be what is resampling. So you don't need to, I no need to repeat, okay, you know. So at this particular stage, definitely you might have know about the resampling. I'm just skipping that part. I'm going for the next one. So what are the important? Okay, that means the importance of reasons. Okay, why we need to do the resampling. So handling the irregular time series. Suppose you are having a continuous data, a very big data set means the data will not be very regular. So irregular data will be available. So if you want to convert the irregular data into a regular data means you can go for the resampling. Okay, that is the first reason. Second reason is reducing the noise. Okay, so if you are going for the higher frequency or okay, the data will be having the lot of noise. So you can do the down sampling, you can reduce it and you can reduce the noise. So this is the second one, reducing the noise. Then enabling the trend and seasonality analysis. So you can identify the trend and you can identify the seasonality in the data by using the resampling techniques. So that means for every cycle, okay, for example, you can see here resampling aligns with the data with the natural cycles, okay, such as the week, month, quarter, okay, highlight period. So what is the concept here means? Data is given, a group of data is given. You can do okay resampling, you can do up sampling or you can do down sampling. So you can do whatever you want and you can find the correct trend and seasonality of your data. Okay, so these are all the importance, and I think some more points also available here. You can see here improving the computational efficiency. Okay, so just go through the points and easily automatically you can explain what exactly that. So if you do the down sampling, you can save that size. Okay, you can reduce the size and automatically it will be speed. Okay, your computation cost will be less. Then aligning with the multiple time series. The time series from different sources may have mismatched frequencies. Okay, if you are collecting the data from 3 different sources, 4 different sources means everybody will use a different frequency. So in that case, so you resampling will help you to have a common frequency among the data. Okay, this is then data augmentation for the machine learning models. Okay, you can skip this point. Okay, you don't need to write. Okay, because you are not studied machine learning in this course. So even up to point number 5. Okay, you can go. It is enough. Or some more points is also available. You can see here detecting and analyzing the anomalies. So already we discussed in lecture number 1. Also, I think what is an anomaly. So abnormal data, the data which is not correct, or we can say it is outlier. Okay, so you can detect the outlier and we can analyze the anomalies and facilitating the visualization. So visualization means like converting, when you convert into a graph or a chart. Okay, if you convert as a plot, automatically you need the data should be in a correct frequency. Then only you will get the clear output. So visualization will be very good if you have a common frequency. So these are all the advantages. Okay, if you are going for the resampling, so these are all the advantage. You can handle your data very efficiently. Okay, so this is a theoretical question only. Question number 19. Explain the concept of grouping in time series analysis. So in the previous questions, we discussed about the resampling. Okay, so that means increasing and decreasing the frequency. Now we are discussing about the grouping. So we have a large set of data, okay, a huge data set I'm having. So what I can do means based on some conditions, I can group the data. So if you group the data, then it will be easy to handle the data. Okay, so grouping. So what is grouping? Grouping time series data. It refers to the organizing and analyzing time series data that is divided into the groups. So we are going to divide into groups based on any particular categorical variable or some set of variables. So your data set is having a lot of variables. So by using a single variable or by using multiple variables, we can group the data. So this is grouping concept. So this approach allows for the comparison and analysis of multiple time series data set simultaneously, and it will be useful for understanding the trends, patterns, relationships, okay, across the different groups. So you can make 2 groups, 3 groups of data, and you can compare your data, okay, compare group 1 with group 2 with group 3, okay, and you can do any comparisons between these groups. Then, so what is the advantage? The advantage of grouping is improved understanding of the trends. So it reduces the noise, simplified analysis, comparative analysis, and then seasonality and cyclic patterns. So you can identify the cyclic patterns. What is the cyclic patterns? What is the seasonal patterns? Okay, how the data is changing. Okay, so all these things you can observe by using the grouping. Now, if you go for grouping, so there are some methods of grouping available. So 4 different methods of grouping is available. You can group the data based on the time based grouping. Okay, so here again the same concept is available. Resampling is one of the time based grouping technique, and windowing or moving average. So moving average is one of the important concept in the statistics. So you can use the moving average, or by using the windowing concept you can do the time based grouping. Then, so categorical grouping, so based on some categories, okay, or based on some variables also you can do it here. And then seasonal grouping. So these two are examples for categorical grouping. Then grouping based on the time windows. Okay, for example, a time period, a fixed time period or a rolling time period. Okay, for every 7 days. Okay, so every 7 days you can have 7 day window. They can shift daily. So you can start from Sunday, Monday, Tuesday, Wednesday, like that. So rolling time windows system you can have. Then seasonal decomposition. So this is one of the technique for making the groups. So what we understand from this particular slide means, or from this particular question, so what is grouping the data and advantages of grouping the data, and what are the different methods available for grouping the data? What is time-based indexing in time series data? So this is indexing. So the indexing is a very important word here. So time series data is very long. Okay, for example, so you can collect the data for a very long period. So this is the time series data. The time series data will be available like this. Now, I want to search some data in this. Okay, so we need to search something. So how can we search means, for example, you can create some index. So you might have already studied this in database or some other courses. Okay, indexing. So what is the use of indexing means, very quickly you can search the data in a data set or in a table. The same concept here. Okay, so you can easily, time series analysis can be done very easily if you're going for the indexing. So indexing, there are different types of indexing available. You can say here date time index, period index, time delta index. So these are the 3 different types of indexing available. You can do it for your data set. So now, what is date time index means? The index type is for the time stamped data. So period index means, so time index for a period, for a particular period, okay, for a week or for a month, like that. So time and delta index. Okay, this is okay mixing. So this types of is indicating the time between the 2 dates. Okay, the time gap between the 2 dates, that is called the time delta index. So You can use any of this indexing technique and you can search the data very quickly in your data set. That means in the time-based data set, time series data. Question number 21. Explain the purpose of time-based indexing in data analysis. So in the previous question, we discussed about what are the different methods of indexing available. Here we are going to see what is the purpose. Okay, so what is the purpose of indexing? Okay, you can see here. So time-based indexing in data analysis refers to the practice of organizing and accessing the data. So very quick accessing the data based on a particular time. So it is particularly useful for time series data where the order of data points is important. Okay, that means every day or every minute the data will be collected. So as they are collected in a specific time interval. So the data will be collected on a specific time interval. For every day I'm collecting the data means so the data will be available like this. Now I want to search a particular data in this means so you need to do indexing. Okay, so what is the purpose of indexing means capturing the temporal relationship. What is the relationship? Then aggregation of and resampling, efficient data access. This is a very important point. So very easily, very quickly you can access the data from your time series data set. Then temporal analysis. Okay, for forecasting also it will be used. Then consistency, you can check the consistency. Okay, you can organize the data. So these are all the other purpose. Okay, the external, the what is it, the additional purpose I can say, but the core purpose is efficient access to the data. Okay, so this is the purpose of time-based indexing in data analysis. Question number 22. Describe the process of visualizing the time series data. So I want to visualize the time series data. That means I want to draw a plot, okay, for time series data. So what are the steps available or what are the process available? Means so visualizing the time series data helps to identify the trends. It will help you to identify the pattern, the variations, seasonal variations. Then you can understand the behavior of the data over a time. So visualizing the time series data. Okay, if you do visualization, what are the advantages? Means these are all the advantages. You can identify the trend, you can identify the pattern, okay, seasonal variations, and you can understand the behavior of the data. Okay, now you can see the steps. What are the steps available for visualizing the time series data? That means what are the steps available to convert your data into a chart? Okay, very simple way. So the first thing, the data should be ready. You must understand the data. What is the data? Then you can decompose the data. Okay, so what is decomposing? Okay, it includes you can remove the noise, identify what is the seasonality. Okay, that means the data is collected weekly or monthly or yearly. Then go for the trend component, capture the long-term pattern over a time. So the duration also you must know. Okay, what is the duration of your data? Okay, how the data is collected? Okay, weekly, monthly, or yearly. Then you can isolate all the noise from your data. So this is going to be step number 2. So first step, understand the data. Second step is decompose the data. Then the next one is the plot trend and seasonality. Now the next one, you are going to start plotting your data. So you can use any technique. So time series plotting. So focus on the long-term pattern. Then plot the patterns across the short time intervals like months or quarters. It's depend. Okay, so you can do any resampling, you can do grouping. Okay, so before plotting your data, you can do anything. You can go for recycling, or you can go for resampling, or you can go for the grouping. Okay, then you can plot your data. Then once if it is plotted, once if the time series is plotted, so what you can do means you can analyze and detect the anomalies or the outliers. So what are all the outlier data is available? What are the anomalies available in your plot? Okay, all these things by using the visualizations, okay, you can find it. Then the next one is a forecasting. So once the time series is plotted means, so based on this, you can predict what will be the next. Okay, what will be the next one? The next data will be how much? Okay, for 12 months of rainfall data I'm having. So based on this, I'm going to predict what will be the rainfall in the 13th month. So there are some techniques available, some methods available. Okay, ARIMA, yes, ARIMA. So these are all the different models available. So using these time series models, you can predict. Okay, what is going to be in the future. Then finally, you are going to create a summary or interpretation by using your plots. So these are all the steps available okay, in plotting a time series data. Question number 23. Define the term third variable in data analysis. So the title of this lecture is multivariable. So here you are going to use more than two variables. Okay, so if you use two variables, it is bivariate. Okay, bivariate analysis, that is lecture number 4, and here it is multivariate. Okay, we are going to analyze more than two variables. So what is the term third variable in data analysis? Okay, so third variable is, it is an external factor that influences the relationship between the two variables. So already x is available and y is having. Okay, y is we are having. So there is a relationship between x and y. Now a third variable is going to influence. It is going to affect this relationship. So this is the third variable. So this variable can cause a suspicious or an indirect correlation. Okay, so it acts as a co-founding or mediating variable. So it can, so in another way I can say, in a very simple way, it can have a positive impact or it can give a negative impact also. Okay, so between the relationships of the first two variables. So co-founding variable, mediating variables. Okay, so there are two different, we can divide that into two. Okay, so co-founding variables and mediating variable. Okay, you can see the mediating variable first so that easily you can understand. So this explains the relationship between the two variables by intervening in the causal pathway. So we already studied about the causal pathway. So in the causal pathway, so either it is going to disturb, intervening, it is going to disturb the relationship between x and y as direct or indirect. Okay, in any method, as a direct method or indirect method, it is going to affect. Then a third variable, you can see the co-founding variables means a third variable that distorts the relationship between the two variables by introducing a surface correlation. So by using some correlation concept, it is going to affect. So third variable plays a major role here. Okay, you can see an example also. If studying the relationship between the hour of study and the exam score. So I'm studying the hour of study. So if I study 8 hours a day, okay, definitely my score is going to improve. Now, sleep quality could be the third variable, sleep quality, that affects both the hour of study and the exam scores. So if you sleep very less number of hours, definitely your score will be very good. Your hour of study is increasing. Okay, so if you sleep more number of hours, it is going to affect the hour of study and also the exam scores. Okay, so this is how the third variable is playing a role here. Question number 24. Differentiate between two variable and a three variable contingency table. So already contingency table you might have studied in lecture number 4. Okay, how to make a contingency table. Okay, percentage table, all these things are already available in lecture number 3. Lecture number 4. Okay, so you can see here two variables and three variables. So if you go for a two variable contingency table means, so this is two variables, variable A, variable B is available. So I'm just giving the values for variable A1 and variable 2, that means A and B, and there are some counts I'm giving. So analyze the relationship between the two categorical values. So a 2D table will be showing the frequency of distribution of the two categorical values. So this is a two variable contingency table. So here it is going to have a relationship only between the two variables, variable A and variable B. So here you cannot explore the interaction between three variables. Okay, because this is two variable. The nature is two variable. Okay, now I'm going for three variables. So three different variables we are going to use. So what are that means? So variable A, variable B, and variable C. So in this case, you can have a different relationships. Okay, many relationships I can say. So variable A and B you can compare. So B and C you can compare. Variable A and C you can compare. Okay, so you can have more than more than two. Okay, relation. That means three different relationships we can compare in this a three variable contingency table. Now, what is the key differences between the two variable and three variable means? So the number of variables are the difference. Okay, these are very simple concepts. Okay, so here two variables will be available and here three variables available. So structure, so 2D table, 3D table. Interactive analysis, okay, identify the simple associations, but here you can identify the complex relationships. So two variable suitable for identifying the simple relationships, and this is for exploring the deeper multidimensional relationships you can identify. Okay, so this is the difference between the two variable consistency table and three variable consistency table. Question number 25, applications of three variable contingency table. So for writing the applications, there is no limit. Okay, so you can write any example where three variables are used. Okay, so I'm just giving a list here. Okay, don't memorize the running text. Okay, if you just know the headings, okay, it is enough. You can write it in your own way. So three variable contingency table is used in examining the relationship between the three categorical variables. So how these variables are influencing, okay, interact and influencing the each other. So it helps to identify the complex relationships you can identify. You can identify the associations among the multiple variables. Okay, these are all the applications. Identifying the interaction effects, exploring the multi-dimensional relationships, hypothesis testing, policy and decision making, market segmentation and targeting. Even you can write it forecasting. You can do, okay, you can do the forecasting. Okay, you can analyze the trend. Okay, you can analyze the seasonality. So all these things are the points. So applications is you can write in your own way. Okay, so there is no restriction for this particular question. So the next question is, explain the construction and interpretation of three variable contingency tables. So they're asking us to construct, to create a contingency table. Okay, now, so three variable contingency tables are useful for analysis. Okay, these are all the points already we know. Now I'm going for the structure. So what is the structure means? Rows and columns should be available. Cells should be available. So if you study this question in chapter number 4, that means in unit number 4 contingency table you can cover here. Okay, now there are some layers available. So rows and columns should be available in the table, cells should be available in the table, and layers should be available in the table. So this is the example. Okay, so you can see this is an example here. I have, okay, 1 2 3, okay, three variables I'm having: high school, bachelor's, master's. Okay, and then some categories: employed category, unemployed category. So you know what is a row, what is a column, okay, what are the cells and all, no need to explain. So for this particular uh, what to say variables, I'm going to draw a causal effect model. Okay, you can see here I'm taking the degrees here. So master degree, bachelor degree, and high school. And here I'm having the employed and unemployed. So now I'm going to have, so master degree, direct influence on both. So for that means it shows that the people with master degree is also, okay, employed. The people with the master degree also unemployed. Same thing. The people with the bachelor degree employed, okay. People with bachelor degree is unemployed. So in all the categories available. Okay, this is what we understand from this table. Okay, so okay, people with high school qualification, 30 are employed, 10 are unemployed. The same thing, master degrees, master people with master degree, 40 are employed and 2 are unemployed. So there is a relationship available between this. So this is a causal model for this data given. Okay, so this is how you can construct a table. A consistency table can be constructed like this. And also the very important thing is the total. The total is very important. If you are going for a consistency table, okay, so you must contingency table. Okay, so not consistency, contingency table. So if you are going for a contingency table, so you have to put the total. Okay, everything, the row total and the column total should be available, and this is called the grand total. So the grand total is also very important one, and it should tally. Okay, so 120 plus 17, 137. So 40 plus 55 plus 42 should be 137. Yes, it is the 137. So this is how you can construct a contingency table. Question number 27. What is a transition table? Okay, so contingency table already we studied in the previous question. Now we are going for the transition table. So what is a transition table means? Is a type of table used to show how the values of variable changes over a time across the categories. So this table is showing the change in the values. Okay, we'll go for an example first. If you see the example, then you can understand very easily. Now you can see here in this example from employed to unemployed. Okay, from one state to another state it is changing. Okay, so the number of people is 200. Then the next immediately what is happening means from unemployed to employed, okay, it is changing as 150. Then again from employed to unemployed, okay, it is changing as employment is increasing here. Then unemployment to unemployment is 1000. So this is called a transition table. So a transition table shows how the data will be moving. Okay, as the time goes, how the data will be moving. That is a transition table. So it provides a structured way to display the frequency of transitions from one state to another state or from one category to another category, highlighting the pattern of the change or the movement between the different states. So from one state to another state, how the data is keep on changing. Okay, so that is called the transition table. So what is the purpose of transition table? So even you no need to read this point. Okay, that means it will make you to understand how the data is keep on changing. Okay, so it may increase the data, the value may be increase or the value may be decrease, but you can understand how the things are moving. Okay, so that is the transition table. So track the movement over a time, analyze the pattern whether it is increasing or decreasing. Okay, stability is there or not. Then it is helping us to make some decisions. So this is the purpose of a transition table. So structure of a transition table is the rows represent the starting of the state or the category. So columns represent the ending state of the category. Then, so the table cells contain the counts of the percentage. That means how much of change, okay, is available. We can find it. So this is about the transition table. So it's a short answer question. Question number 28. What is a multivariate analysis? So there's a core topic of this lecture. Okay, so multivariate analysis. So analyzing more than two variables. So multivariate analysis refers to a set of statistical techniques used to examine the relationships between multiple variables. So the multiple variables only I'm telling more than two. Then, so we have univariate analysis. So lecture number 3, bivariate analysis, lecture number 4, and we are now in multivariate analysis. So you focus on one or two variables, but multivariate analysis considers multiple variables at once to understand the combined effect and interactions. So univariate means one variable, bivariate means two, multivariate means is going to be more than two, or we can say multiple. Then what are the characteristics of multivariate analysis means? So simultaneously you can analyze the multiple variables. So the same point is repeated more than two variables here, and this will help you to capture the interactions between the variables. Okay, complex interactions. Okay, complex relationships you can find it. Then there are some methods available here, some statistical methods available for multivariate. One of the very famous is MANOVA. So multivariate and analysis of variance. So this is a very popular method available. So there are some techniques available like multivariate regression technique is available, factor analysis available, cluster analysis, principal component analysis. Okay, these are all the common methods used, okay, for multivariate analysis. Then you can have multiple correlations. So x comma y, y comma z, x comma z. So multiple correlations you can find it here because it deals with the multiple variables. So this is about the multivariate analysis. Question number 29. What are the two common techniques used to perform dimension reduction? Okay, so first we have to know what is dimension reduction. Then we can go for the two common techniques. Okay, so what is dimension reduction means? Reducing the number of variables. That's it. I have, okay, 10 variables in my data set means, so no need to have all the 10. So you can reduce it to 4 or 3 or 2. So this is called, okay, dimension reduction. So it's a process of reducing the number of variables or the features in a data set while retaining as much of the original information as possible. Okay, it should be like a same original the data set, but it should be reduced. Okay, for example, like a city, street name, okay, door name, okay, your flat name, all these things we can convert as a single field like address. So this is dimension reduction. So address means everything should come in that. Okay, so the goal is to simplify the data and to reduce its complexity, making it easier for analysis and visualizing, and also reducing the computational cost. Okay, so objective of dimensional reduction. So what is the Objective means reducing the noise, minimizing the correlation, minimizing the number of variables, minimizing the processing time, minimizing the data. Okay, you can write it in your own words. So enhancing the interpretability. So these are all the objectives of dimension reductions. Now, actually the question, if you see, two common techniques. What are the two common techniques available for dimension reduction? That is the main question here. So the two common techniques is, the first one is the factor analysis and second one is the exponential smoothing. So these two techniques can be used. Exponential smoothing is a very popular method for forecasting the time series. So using the exponential smoothing method or the factor analysis. So this is also for what is it? For reducing the number of variables. Okay, it will also reduce the number of variables. So by using any of this method, okay, you can do the, so you can go for the what is it, dimensions. That means reducing the dimensions you can. So next question, a very simple short answer question. What are the characteristics of multivariate analysis? So these are all the characteristics. There are 7 characteristics given here. So multivariate analysis means simultaneously analyzes multiple variables. Then identification of complex relationships and interactions between the variables. Okay, so no need to explain. The words are very clear. So using the statistical model, so we already discussed a model, okay, the name we have given. So using the statistical model, you can do the proper analysis. So predictive power, okay, that means the forecasting. So it will have a very high forecasting power, and then data complexity will be reduced, and exploratory or confirmatory approach. So you can have a exploratory EDA method you can have, and you can analyze all your data. Okay, so this is the characteristics of multivariate analysis. Question number 31. What is TSA? So TSA stands for time series analysis. So TSA in data model. So time series data consists of sequence of observations collected at regular intervals of over a time, allowing the analysis of the trends. You can allow, okay, you can identify the trend, you can identify the cycle, you can identify the pattern. So all these things you can do. Okay, now if you take a time series data, definitely it will be in a chronological order. So what is chronological order means, like from small to big. Okay, so not small to one, like old to the new. Okay, that means the data which is collected newly will be available as the first, then followed by the other data. Okay, that means today's data, yesterday, day before yesterday. Okay, it goes on like that. So that is a chronological order. So the data will be managed in a chronological order. Then even intervals will be available. Okay, if it is collected, okay, based on the interval. If you collect every minute, okay, the data will be available for every minute. If you collect the data for every second or every day, every week, so whatever the time duration, the period you are following, the same thing. Then the time series frequency will be followed, the same frequency. Okay, this is the same, almost second and third point will be same. So based on the daily or weekly or monthly or annually, even for every second, so you can have any frequency and you can collect the data. Then, so uses of time series analysis, if you see, so time series analysis are widely used in the various fields like finance. The major field is the finance. Okay, so forecasting the stock price. Then economic, okay, for to find the GDP. Then environmental studies, okay, climatic, temperature, okay, all these things. Then and many other applications are available where the time series data is used. Even for the health, okay, for health monitoring, okay, healthcare, even in the finance, okay, income based. So there are so many applications available where the TSA is used. Okay, this is a time series data example. So this is the number of visitors in a park. Okay, so we are having the two things we are collecting, two data we are collecting. One is the visitors per month and also the temperature in the particular park. Okay, so the data is collected like this. So this is the date. So first, okay, 2014, then 7 2014. Okay, this is a month. Then 2015, 15, 2016, 16. So it is almost 3-year data, 14, 15, 16. So 3-year data is available. Then the number of visitors we are collecting, and then the temperature is also we are collecting. Okay, so one line is going to be the number of visitors, how many visitors every month they're visiting the park, and what is the temperature, okay, for all the 3 years. Okay, so this is a time series data example. Question number 32, write about the characteristics of time series data. So time series data is always a structured data. Okay, it will be having a proper structure. A chronological order will be available. No updates on the data. You cannot change the data. Once if it is collected, it is collected. That's it. Okay, we cannot go and change. Suppose if data is missing, you can fill. But if the data is available, you cannot change. Okay, then single data source. So it's about a single entity. Okay, the data is collected about a single person or a single object. Okay, whatever it is, it's a single data source. The ratio of read is higher than the write is lower. So the reading the data will be more, writing the data will be very less. So the trend is more important here. You can easily identify the trend, whether okay the increased trend or decreased trend, or whether the trend is maintaining in the same level. Then you can do the aggregation over a time. So what is aggregation? We already studied. So you can do all types of aggregation, okay, on your data. Then real-time compounding is required. Traffic is stable. Data volume is going to be very high. So these are all the categories, the characteristics of time series data. So if you understand the words, easily you can write it by your own words. Okay. So with this, we are completing part A questions of unit 5. We are going to the part B questions. If you thorough with all the part A questions, answering part B question is not going to be a difficult one, because I already explained all the concepts in part A. So part B questions will be a combination. So it will be a collection of questions from part A only. I'm not going to explain all the answers here. I'm going to show the question and I'm going to give the points. So what are the points you have to write? Because almost we covered everything. The entire unit we covered in part A. Okay, now let me go to the question number 1. Question number 1, okay, part B, 16 mark question. You can see what are the characteristics of multivariate analysis. How do you explain multivariate analysis? So you can find the answers from the part A, but I'm giving the points. What are the points you have to write? See, first write what is a multivariate analysis. Second, write the characteristics of multivariate analysis. So you can find the answers from part A questions. Then 3 variable contingency table. What is the table? Okay, what is the structure of the table? How to construct the table? Then you can give an example table. Then for this particular table, go for a diagram. Okay, you can just go for a causal path model. Okay, you can draw a diagram for this particular variables. Then you can give the applications. What are the applications of multivariate? Okay, so public health. You can give your own answers. Okay, marketing, finance, share market. So these are all the places where we are using the multivariate analysis. So this is how you have to answer this particular question. Question number 2 and 3. Okay, so describe how introducing a third variable enhance the understanding of the relationship between the two other variables. Provide example to illustrate its impact, or illustrate the process of establishing the causal explanations. So the question is, it is about the 3 variables. Okay, you can see here. I'm going to introduce the third variable. What is third variable? What is a causal explanation? So this is the first question, I think, part A. Then what is causality? What are the types of causal effects? Okay, direct and indirect. I'm giving an example here. So don't follow the same example. You can give your own example. Then what are the importance of causality? Then hypothetical example. So what does that mean? This is step by step they will give. Okay, you can give the step by step of construction the diagram. Okay, so first one, this is the first relationship. So this is the second relationship. Okay, so you can just draw in the steps. Finally, you will get this diagram only. Okay, you are going to get this. So here, what is a direct relationship? What is the indirect relationship? And all you can explain. And finally, we are going to have the overall diagram. You can give it. So this is how you can answer this particular question. Question number 4 and 5. Explain about the causal path model for 3 variables. The same thing question is repeated. Or describe the application of 3 variable contingency tables. So almost things are repeated here. So you can write what is a three variable contingency table means what is the structure of the table. You can give an example for the table. Okay, I'm giving an example. Then go for the causal path diagram. Okay, then interpretation. So interpretation means, so from by using this diagram, what are the things you can understand? Okay, that means what are the things you can interpret. Okay, insights, or we can say the results, what you can discover. Okay, so the associations, that means the relationships. Chi-square test you can use, conditional probabilities use chi-square test. It is available in lecture number 4, so kindly go through it, and these are all the applications. So you can see here from question number 6 to 12, so all the concepts we already discussed. So let me read the questions only. Okay, discuss in detail about the data cleaning, missing data, outlier reduction, and treatment. Explain the cleaning procedure of our time series data. Explain the significance of longitudinal data in trend analysis. What is meant by time series data? Describe its components. Illustrate the importance of resampling in time series analysis. Explain the concept of resampling in data analysis and discuss the key components, types, significance, and resampling in data analysis. Illustrate with examples resampling techniques like downsampling, upsampling, handling the missing values through the methods such as the forward fill, backward fill, and interpolation. So, all the questions, the answers you can find it in the short answers. Now, I'm going for the last question here. So this is something new we didn't discuss. Okay, so the last question is explain Simpson paradox. Include its characteristics, the role of allocating variables, and provide an example. So you can see the 14th question also discuss how the Simpson's paradox can lead to misleading conclusions if not properly accounted for in data analysis. Okay, so this is a very important question, and this is going to be the last question. Now, Simpson's paradox. What does that mean? It's a phenomenon. It's a statistical concept where the trend that appears in several different groups of data can disappear or reverse when these groups are combined together. So we already discussed about the grouping. So we can divide the data into groups. Okay, so we're done. So once if you've done the grouping, you will be having a different results in each and every group. Now, I'm going to combine all the groups together. So if I combine these groups together, I'm going to get a different answer. So this is called Simpson paradox. So where a trend that appears in several different groups of data can disappear or reverse when these groups are combined. Okay, so this paradox highlights the importance of considering the context and the influence of lurking the variables when interpreting the statistical results. So this is what to say. This is a phenomenon. Okay, so where we have to observe it very carefully while doing the data analysis. Okay, so individual data may give you some result, but if you combine all the data, that means all the groups together, you will get a different result. Now, so what are the key characteristics you can see here? So grouped data. So the paradox occurs when data is divided into subgroups. Then a specific trend is observed within each subgroup. Then when the subgroups are aggregated, the overall trend can contradict the results observed in the individual groups. We are not getting the same result what you followed or what you found in the individual group. Okay, so this is now Simpson paradox often arises due to the presence of confounding variables that influencing both the dependent and independent variables and obscuring the true relationships. So this is why actually let me tell for what reason this will happen means the relationships will change. For example, in group 1 you will be having a different variables. In group 2 you will be having different variables. In group 3 you will be having different variables. So there the impact or the relationship will be different. So when you combine all these groups together, so the way the variables interacting is going to be different. So what you observe in the individual groups, definitely it is not going to be here. Okay, so this is what the key concept of Simpson paradox. So let us see an example here. This is a table, so related with the graduate school applications. So there are some departments available, A, B, C, D, E, F. Okay, So men accepted, men rejected, women accepted, women rejected. So these are all the percentage and also the number is available. Now you can see the department level in department A and B. Okay, so this is the department A and B. Women have higher acceptance rates than men. Okay, so women 82% is accepted. So women here also it is 68% accepted, but here it is 63. Men is 63, and here men 62. So women acceptance rate is very high. But what is the fact means? The fact is nothing. You see here, 512 men are accepted. It is 62%. And here it is 89 only 80 to 89 women, but the percentage is 82. So if you see this percentage, you are getting a different answer, different perspective. That means more women is admitted in department A, but it is not true. Okay, but it is not true. The reason is, okay, if you see the real number, it is 89 only and 512 is. Okay, here 512. So this is the essence of paradox, the Simpson paradox. So by seeing the percentage, I'm getting a insight. Okay, I'm saying that more women are accepted in the department, but if you see the count, okay, it is not true. The count is only 89. Okay, so this percentage only for the women and the number of women. Okay, they are calculating. So this is a simple example where Simpson paradox is applied. Okay, so what does this means? The overall analysis, if you see, okay, the men have higher overall acceptance rate 44 compared to the women. So this example demonstrates the Simpson paradox. Although the women may perform better in specific departments, the overall results suggest that the men are more successful in gaining the acceptance to the graduate school. So this paradox emphasizes the importance of analyzing the data at multiple levels and considering the influence of the third variable to avoid the misleading conclusions. Okay, so this is about the Simpson paradox. So you can give your own example and you can write about the concept. Okay, so with this we are completing this lecture. Thank you very much. All the best.